Welcome to the How to Program with Java podcast, where all you need is the desire to learn, and you too can become a Java programmer with absolutely no knowledge of programming. And now, your host, Trevor Page.
All right, hello everyone, and welcome back to episode number 20 of the How to Program with Java podcast. Holy crap, it's episode 20 already. So, let's start the show off like we've been starting them off in recent past with reviews. I actually got two different 5-star reviews from the UK, which is awesome. I'm getting a lot of love from the UK these days. The first one comes from a gentleman named Rodrigo. He says, "Hi, this podcast is what I was waiting for ages. Trevor is a great teacher. The way he explains all this programming topics makes them appear less complicated, even for a beginner like me. Thank you very much, Trevor, and please do not stop teaching us." Well, it is my absolute pleasure, Mr. Rodrigo, to go through all this stuff with you and with everyone else who's listening right now. So thank you very much for that feedback. And also, we have one from, it looks like Donald. He says, I'm 5 podcasts in, and I want to thank you for doing this. 5 stars, very well earned. So there you go. This is number 20. I guess Donald is on number 5, so he's got 15 more to go to catch up before he'll hear this. So hopefully when he does, he smiles and gives me a nod through the virtual airwaves. So, cool. Let's move and sail right on into our topic for today. I was going through my my list of topics that I want to be covering, and I realized I haven't yet talked about a fairly common thing in programming known as casting. So I figured, hey, why not make number 20 a show about casting? So that's exactly what we're going to be talking about today. So let's kick off this podcast episode with a quick explanation on what exactly casting is in general. Okay? So casting exists in today's object-oriented programming languages as it's the means by which we turn one object type into another object type. Okay, so converting from one to another. So think of it, my stupid analogy that I thought up is think of a caterpillar turning into a butterfly, only without the whole annoying cocoon stage. So in Java, and believe it or not, other object-oriented programming languages, we can literally take an object of one type and turn it into another type with one line of code, just like a caterpillar would turn into a butterfly. So I'll get into what the code is in just a moment, but first I want to give you a little more background on the casting topic itself. So let's talk about what casting is all about. In Java, casting is all about moving around the hierarchy of an object. Okay, so you remember that there is this thing called hierarchy in Java programming, and it's what we use to represent the sort of stages that an object can exist in, or the states, I should say, that an object can exist in. So to explain that concept, I'll use an example. So picture the following hierarchy. We have object at the very top, and then underneath we have mammal, and then underneath that we have human. Okay, object, mammal, human. So on the most generic end, at the very top, we have the object. But then, as we get a little bit more specific, we hit the mammal type. Okay, so we go from the object to the mammal. And then, to even more specific, the most specific in this example, we move from the mammal to the human. Okay, so given this example, what do I really mean by moving around the hierarchy? Okay, because like I said, casting is all about moving it around. So consider the most generic type that we have, that I just explained in our example, which is the object. What sort of operations can you think of that we can actually perform on the object itself? So how about, can you ask an object what its name is? So can we just say object.getName? No, because it's an object. It only has a handful of operations that you're actually allowed to perform. Okay, namely, toString, hash code, and equals, among a few others. So those are the generic things that an object allows you to sort of invoke on itself, okay? So do you see how asking an object what its name is doesn't really make sense? Okay? So on the contrary, you can look at the most specific type that I talked about in our example, which is the human. So does asking a human what its name is make sense? Well, I'd like to say that yes, it does make sense, because I would assume that all humans would have a name, okay? So, do you see how the type of an object that you're looking at in particular, in the particular hierarchy, is important when you're deciding what methods to invoke? Okay? It is very important, because like I said, you can't ask an object what its name is, but you can ask a human what its name is, okay, given that obviously it's programmed in there. So it matters which part of the hierarchy you're looking at when you're asking to invoke a certain method, or even just look at a property, okay? So if the, property exists inside of an object that is publicly declared, then you can get access to it. But again, you need to be looking at the right type of object, okay? So, how does this apply to casting? Well, casting is what allows you to change the object you have into a more specific type of object with the goal of gaining access to the additional methods or properties that exist inside of that more specific type that you actually want to use, okay? And when we're talking about casting, there's actually two types of casts that you can do. You can upcast and downcast, okay? So just like I was saying before with our example with the hierarchy where object is on the top, and then it's mammal in the middle, and then it's human at the bottom, when we're talking about upcasting, we're talking about going from the bottom up, or when we're talking about downcasting, we're talking about going from the top down. Okay, so we're moving down the hierarchy for downcasting, we're moving up the hierarchy for upcasting. Okay, so if you can, I'm sure you can picture that, the three different types of variables here, the object at the top, then mammal, then human. If you point an arrow down that and getting more specific, that is a downcast. And if you have an up arrow pointing from the bottom up, then it's an upcast, okay? So, having said that, upcasting is the simpler of the two casting options. And this is because it's always safe to upcast. So let's think about this for a moment. If you're given a human object, would it make sense for you to upcast that to a mammal type? Well, of course it would, because a human is a mammal, okay? And this should really be ringing bells in your head and thoughts of inheritance in your brain. Inheritance is all about the is-a relationship, okay? So since a human is a mammal, then we can easily cast a human into a mammal. Does that make sense? So the side effect of that is that we will lose whatever functionality that was specific to the human type. So if the human type was, had a name property defined inside of it, we will no longer be able to access that property when we upcast to mammal. Okay? We will still be able to access all the methods and properties that are specific to the mammal class, though, like, let's say, eye color. Okay, I assume that all mammals have eyes and perhaps an eye color. I'm, thinking in my head, does that make sense? I'm hoping so. I don't want to make a fool of myself, but who cares? Whatever. Let's assume that all mammals have eyes and they can have an eye color. So then, since we're still talking about upcasting, you could upcast your mammal variable then to be an object type, if you like. Okay? Because since a mammal is an object, then the upcast makes perfect sense. But the same thing's going to happen that happened when we moved from human to mammal. When we moved to from mammal to object, we lose some functionality there, okay? So like I was saying with the eye color, now if we have an object, asking an object what its eye color is doesn't make any sense, okay? So there you go. That's upcasting, pretty straightforward. So now let's flip things around and talk about downcasting. This concept of downcasting is just like an upcast, only it's in reverse. Big surprise. So we're taking a more generic object, like mammal, and trying to cast it down into a more specific type, like human. Okay, so mammal to human. Okay, see how that's a downward move in the hierarchy. So all the things I mentioned before about functionality still hold true here, only this time you're going to be gaining more functionality rather than losing it, as we are getting more specific in our hierarchy, okay? So previous we had mammal, which had something like an eye color, but we couldn't ask a mammal what its name was because maybe not all mammals give themselves names, okay? But if we move down and cast it down to a human, then it makes sense to ask a human what his name is or her name is, because hopefully all humans have a name. So what changes here, the main difference between upcasting and downcasting is that with downcasting, it can lead to errors if you're not a bit careful. Okay, so this goes back to my talk in inheritance about the direction that the inheritance flows. So to refresh your memory, I said that you could use the following exercise and ask yourself if all objects of one type would belong to another type. So to give context to that with our example, we would ask, are all humans mammals versus are all mammals humans? Okay, so the answer is yes, all humans are mammals. Does that make sense? All humans should be mammals because it just makes sense. All humans are mammals. But the other way around, I would say no, that to not all mammals are humans. That doesn't make sense. Not every single mammal that exists on planet Earth is a human. It doesn't make any sense. You can't say that. So because of this, it's safe to cast any human into the category of mammal, okay, because all humans are mammals. But on the flip side, it's not safe to cast any mammal into the category of a human. Okay, you see where I'm going with this? So since not all mammals are humans, if we try to downcast a mammal to a human, we should be sure that the object in question really is a human. Otherwise, we get something called a class cast exception. Okay, we're trying to cast a class into a more specific type of class, and it just doesn't make sense, so we get an exception. Okay, so an example of that is, let's think of another type of mammal. Let's think of something like, an elephant, okay? If we have a mammal defined in our code, but that mammal really is an elephant, okay? It was maybe instantiated as an elephant, but we are programming to, let's say, an interface. So we say, mammal, a mammal equals new elephant. And then we try to cast that, a mammal variable into a human, then that doesn't make sense. You can't cast an elephant into a human. It doesn't make sense. So we get a class cast exception. All right. So that's downcasting, and that's a bit tricky because you need to make sure that the object in question really does belong to the class that you're trying to cast into. So in order to do that, there is a way to verify if your object is indeed a correct type, like a human, before you try to cast it. But I'll touch on that a little bit later. So all this talk about the implications of casting, but I still haven't yet explained why we would cast. So there's a couple of reasons I can think of off the top of my head why one would need to perform a cast in Java. The first reason I can think of is that casting is that you would want to cast to a more specific object type to get access to some additional functionality. Okay, and another reason would be that casting to a different variable type could be required in order to comply with some sort of restriction on the type inside of a method signature or a constructor or something. So let me elaborate on both of those reasons. So the first reason we've already touched on a little bit, but let's use a bit more of a common example than the human and mammal example. So when we're talking about casting to a more specific object type to gain that additional functionality, a good example would be talking about a collection. Okay, and if you're not familiar with what a collection is, then I'd suggest you go back in the podcast history and listen to more of the shows. And if you listen to that show already about collections and just forget, I'll jog your memory here. a collection is Java's sort of generic interface that is used to represent its data structures. So common collections in Java are the list, the set or map, those kinds of things. Okay, so that's what a collection is. So let me give you another example of a type hierarchy. Okay, so consider this one: collection at the top, and then list, and then array list. Okay, so just like we had before, we had object, mammal, human. This time we have collection, list, and array list. So what would happen if you had a method defined that takes a generic collection type, and within the method you want to use the functions of an array list? Well, you wouldn't be able to access all the methods in an array list until you casted that variable from the generic collection type to be an array list. Okay, just like if you were to cast an object to be a human. All right? So let me say that again. What would happen if you had a method defined that takes a generic collection type? Okay, so inside the method we ask for, collection and then, variable name for the collection. And within that method you want to use the functions of an array list. Okay, so the array list allows you to do things like, getting from the array list, removing from the array list, and all that stuff. But those methods are not defined on the collection interface. Okay, so you wouldn't be able to access the get and the remove and the whatever because the variable's type is declared as a collection. So in order to get access to the array list methods, you would have to cast that variable to be an array list. Okay, so that's opening up more functionality that you can use inside of your code. Okay, and again, you would need to make sure that you know that cast is allowed. So again, we'll touch on what you can do to ensure that is going to be a valid cast, so that we can avoid getting a class cast exception. So fair enough. What about the second reason I mentioned for why we would want to cast an object? Okay, the second reason was casting to a different variable type may need to happen because we are required to do so based on the method signature or something like that. Okay, so sometimes you need to comply with types that are defined in certain methods. Okay, so normally, if a programmer is properly doing his job and he's programming to an interface, then you should be safe with passing in your specific object type. Because then, if it was expecting a collection and you passed in an array list, then it's fine. An array list can cast up to a collection, and no extra code is required, and that's always valid, and Java takes care of that for you. But there are some cases when a method will take a very specific parameter type, and you'll need to cast your variable in order to comply with that method signature. So an example of this would be, let's see, if we had a method specifically needed an array list, and the variable you wanted to pass in was declared as a, let's say, more generic list type. So this type of casting doesn't happen often, but I've definitely encountered it before. So again, you have a method signature that's expecting something specific like an array list. Okay, so I want you to pass me an array list, but what you have is a generic list type. So this variable was declared as a list, and you actually won't be able to pass it into that method without casting it down to an array list. All right? So that's kind of annoying. So that's why we always want to program to interfaces, because interfaces are usually more generic and they allow for more flexibility with your coding. Okay? So now that we've talked about all that stuff, how do we actually cast already? Okay, let's talk about a little bit of code. So you're by now hopefully you're pretty familiar with the concept of casting and upcasting and downcasting and whatnot. And but the question is, how do we actually accomplish this in code? Well, it's actually pretty simple. Like I mentioned, it's really just one line of code. All you need to do is figure out what variable type you want to cast to, and then you just include that in parentheses, or parentheses, however you want to pronounce it, before your actual variable name. Okay, so I'll elaborate on that. So let's talk about the list and array list example. Let's say you have two variables. One is called my array list. The other is called your list. Okay, so let's assume that my array list is defined as an array list, and your list is defined as a list. All right, pretty self-explanatory. My array list is an array list. Your list is just a list. So now let's say that we want to assign my list to my array list. All right, so we actually want to replace what's in my array list with the object my list. So what you could do is you could try to write that out. You could just say my array list equals my list. But you will get a compilation error. And it will state that you need to cast my list into the array list type. Because again, you're trying to take my array list, which is of type array list, which is a very specific type, and you're trying to replace that by saying equals my list. And you're trying to replace that with a more generic list type. So that doesn't work because you're taking something more generic and you're trying to set it equal to something more specific. So in order to do that, you need to downcast, okay? So all you need to do to fix this scenario is you need to add the word array list in brackets before the my list variable, okay? So what that would look like in code is, previously I said you'd have to say my array list equals my list. But that's incorrect because you need to downcast. So to fix that, you would say my array list equals array list in brackets and then my list, okay? A lot of words, a lot of, trying to talk it out in code is obviously very difficult. So as always, I will tell you, you can go to howtoprogramwithjava.com/session 20, and you will see exactly what I'm talking about. Just about more than halfway down the page, you'll see some code snippets, and then you can see what I'm talking about. But really, all you need to do is you need to add the type of the variable that you want to cast to. You include it in brackets before your actual variable that you want to be casting. Okay, so since we want to cast my list, before my list, we put array list in brackets. And then there you go. That's the cast. Done. I also have a little tip on the website about downcasting and accessing the more specific methods when you are downcasting. So by all means, go over there and check that out because that's kind of I call it a gotcha. Sometimes you do the cast and then you try to access the methods and the properties that are part of the more specific type that you're casting into. And you can't. You hit the dot property to, you hit dot to look at the new methods and stuff, and you don't see them listed, and you say, well, why is that? Well, there's just a little bit more that you need to do to get there. It's very simple, but I have that outlined on the site as just a little quick tip there. So head over there and check that out. So before we finish up here, I want to now talk about type checking before we cast. So I mentioned that there's something that we can do to check the actual type of the variable to see if it's equal to the type that we want to be casting to or downcasting into, okay? So this is sort of the means by which you can safely cast, okay? So if you want to do a bit of testing to ensure that a cast will work in your code, you can use the instance of keyword, okay? Instance of. It's all one word, all lowercase, okay? That's actually very important that it's all lowercase because remember, Java is case sensitive. So all lowercase, instance of. So an example of that would be something like, okay, we have a variable that's called mammal variable, okay? And let's say that mammal variable was declared as a mammal, but we instantiated it as a human, okay? And that's perfectly legitimate. That's exactly what we're doing when we say declare a variable as a list type, and then we instantiate it as a new array list. So list is the more generic type, and we're instantiating it as an array list, which is a more specific type. That's called programming to an interface. So same thing's happening here. We have a mammal variable declared as a mammal type, and we are instantiating it as a human type. Okay, human is the more specific, mammal is the less specific. Okay, so we have a mammal variable, and we want to cast that mammal variable to be a human. But before we do that, we want to make sure that the actual variable itself is indeed a human object. So what we do is we use the instance of keyword. So we can literally just say if mammal variable instance of, again, all one word, human, so you put the actual class, the human class. So for Java conventions, you'd have a capital H followed by the rest of the human word all in lowercase. So that's how you would do it. You'd say if mammal variable instance of human, and then you would do your cast. Okay, so that way Java will check and make sure that your mammal variable is indeed of type human somewhere in its hierarchy. And if it is, if that works, Java will say, okay, that's true, and then you can go in and actually carry out your cast. If the mammal variable, let's say, was instantiated as an elephant, then checking to see if mammal variable is an instance of human will actually fail. It will say false. So then you can actually, avoid trying to cast an elephant into a human, thus saving the world. Make sense? I think so. So, but again, you can, if you are not fully picturing that well enough, you can go to the website, and I do have that example on the blog. So, now, one more thing that I want to leave you with before I end it is a little exercise for you to try yourself at home. So I call this fun with casting. One thing that you can try for yourself is trying to convert a primitive type into another primitive type. Okay? So for example, what do you think would happen when you have a double? Okay, so remember a double is just a number with a decimal value, so like 2.2, and you try to cast that double into an int. Okay, and remember an int is a whole number. Okay, there are no decimals in an int. So what happens if you try to take 2.2 and cast it to an int? All right, good question. And vice versa. What happens if you have an int, like let's say 1, and you try to cast that into a double? What happens? Well, I leave that to you to find out. So go home, fire up your IDE of choice, and try to actually do that casting yourself. So remember, to cast things around, even with primitives, you have to enclose the type in parenthesis, and that's the type that you want to cast to, and you put that just before the variable that you want to actually be casting. All right? So there you have it. All the nail-biting and intense action that is a Java cast in under 30 minutes. All right? Very exciting stuff. So, yeah, awesome. As always, it's a pleasure doing these things. And I guess I will end the show by saying thanks so much for listening and for, leaving these awesome 5-star reviews. And I'm getting more and more people signing up for my Java video tutorials course that say they're signing up specifically because they heard about it through the podcast. So, I mean, that's awesome. That's wicked. I've like I've said before, I've recently started this entrepreneurial venture, which is the Java video tutorials stuff, as well as publishing an ebook. And I'm doing it full time right now. I actually left my 9-to-5 job to do this stuff. So hearing that people are actually signing up and loving the course that I've actually created, because that they found out about it through the podcast, that's just so cool to me. That's so awesome. And the feedback that I've been getting from these students in the course has just been fantastic. I actually implemented a little video that described how I created an enhancement in that code where I asked students in Java video tutorials to rate the actual course. So I made a set of videos to show exactly how I went about coding that solution, and you can get that if you like by signing up to my mailing list at javavideotutorials.net. And now the results are starting to come through, and so far the average rating I've received out of all the users has been a 9.5 out of 10. And that's just so That's amazing. I mean, I would never have expected a 9.5, maybe a 7, an 8, but no, these guys absolutely love the course. So, maybe you will too. I don't know. If you're really serious about learning Java, then I would really, really recommend you go over to javavideotutorials.net and check it out right when you get home. All right? So, as always, take care, everyone. Happy learning, and bye for now.
Thanks for listening to the How to Program with Java podcast. Please visit howtoprogramwithjava.com for more useful Java tutorials.